Okay, so we are now in Unit 5, Day 3. So we're going to talk about the first derivative test now to get local extrema. So in Day 2, we found how to get the absolute extrema, and that's what that candidates test. But we're going to be talking about how to find local extrema, and through that, we're also going to be determining when the function's increasing and when the function's decreasing based on the first derivative only. Okay? Okay. So let's make sure we understand increasing versus decreasing. So here I can see that on this interval and on this interval, the function would be increasing. So we're increasing from 1 to 4 and 6 to 7, and then decreasing on the other two intervals. So what do we notice about the tangent lines, of all the tangent lines of what's going on? Okay, so when we are increasing, the tangent line slopes are positive, aka that's where f prime is greater than 0. And that's what we're going to be looking for. If I want to know where the original function is increasing, I find where the first derivative is greater than 0, decreasing less than 0, constant 0. And that's what this is telling me right here, okay? Now, we have to have a continuous and differentiable function. We know we love our conditions in order for this to work. Okay, so let's talk about the first derivative test. So if I have this continuous interval, okay, that is differentiable, and let's say that f of x goes from increasing to decreasing, then what do I know that point right there is? That x value is going to be a relative max. If I change from decreasing to increasing, then what is this x value? That x value is a relative min. Now, sometimes we're going to see where we can go increasing to increasing still, and we have this like weird change in concavity, and that's okay. Okay, we can go like concave up to concave down, but it doesn't change the increasing and decreasing. That's going to be called a point of inflection, which we will get to more. Okay, so for relative extrema, and that is not the same as absolute. Remember absolute, we've got to do the whole candidates test. We're going to go find the first derivative, get all the critical numbers, and then if we had just one critical number, that's different, but if we had a closed interval, we could do what we just talked about with the candidates test. But if this is an open interval, I should put on open interval, okay, then we're going to make this number line, and we're going to divide it into all of the critical numbers. And we're going to look and see what happens to f. Does f go positive to negative? That means does f prime go positive to negative? Then f would go increasing to decreasing, making that a relative max. Does f prime go negative to positive? If so, I went decreasing to increasing, making this a relative min. Now, if those are holes or discontinuities, then they wouldn't be relative extrema. Just make sure we remember that, okay? Okay. So let's do one. It wants me to find where this function is just increasing and decreasing, and then what the relative extrema are. And see, we do not have a closed interval. We've got to get a number line now. It's an open interval. So I'm going to take the first derivative. I'm going to set that equal to 0. I'm going to find also or DNE where it doesn't exist, okay, for critical numbers. And I see that x equals 0 and x equals 4 are my critical numbers. So then I'm going to go do a number line with 0 and 4. And I'm going to see what happens for f prime. So I'm going to go plug these values into the first derivative. So what's a value less than 0? So maybe I'm going to go plug in -1 because it would be something over here. When I plug in -1, I just want to know, do I get a positive or a negative? So this, when I plug in -1 here, would give me a negative times a negative, which is positive. Okay, let's plug in a value between 0 and 4. Well, what's the easiest one? 1. So I'm going to plug in 1 here, I get a positive. Plug in 1 here, and I get a negative. So I can see that this is negative. And then let's get a value after 4. The easiest one, just keep it simple, is 5. Plug in 5, I get out a positive times a positive, which is a positive for f prime. Now, we could have plugged them into this top one as well, because that's an equivalent thing, but it's just easier usually to plug them into the factored one, because we're not trying to find the number. We're trying to save time, be efficient, and find if our overall answer is positive or negative. So then we're going to say, what does that say about f? That says that f is increasing here, decreasing here, and increasing here. Now, that whole number line doesn't give us any points. That's just our thinking, and it definitely helps us a lot, okay? But now we have to go like explain it in words. So f is increasing on the intervals from -infinity to 0 and from 4 to infinity. To infinity. And if they wanted to know why, we would say f prime is positive on those intervals. So f is decreasing on the interval from 0 to 4. And if I wanted to know why, f prime is negative on those intervals. Okay, I also know that I have a relative maximum. Think about what the shape of this looks like, right? So I have this relative max at 0. Oh, what is my y value? We haven't found that yet. So let's go find f of 0. Oh my gosh, you guys, do you know what I just realized too? I left off my primes here. Yay! Those were all primes. I was plugging them into f prime. Okay, so now I want to go plug them in to the 0 to find my output value. So plugging 0 in, I get 15. So the relative max is 0, 15. That's a point. And if I said y, I'd say f prime goes from positive to negative at x equals 0. And then I have a relative min at 4. Go plug that into your original function. See what you get. See, and pause me. See if you get the same thing. I got negative 17. And why? Because f prime goes from negative to positive at x equals 4. Okay? Okay. Next one. I want to know, again, the increasing, decreasing, and the relative extrema for this. Now we're going to also have to pay attention to some discontinuities. I'm going to go ahead and get my first derivative. Pause me. You go ahead and get your derivative, get it simplified, and when you're ready, unpause and see if you get the same thing as me. This is all I see on your paper. I know you're just copying. Okay, go do your work and see if you get that. Okay, so where does this guy equal 0 or DNE? Well, it's going to equal 0 when the top is 0, and it's going to equal DNE when the bottom is 0. So on this one, I'm going to go ahead and see if it factors, which it does. And I get some critical values of -3 and 1. And then also over here, this happens twice, but -1. Okay, so those are all my critical values. So now I'm going to go ahead and set up my number line. I'm going to put them in order, and then I'm going to go and plug in values to f prime that are between these. So for instance, I would find f prime of -4, f prime of -2, f prime of 0, and f prime of 2. That's what I would pick. So I want you to go plug those in and see if you get positives or negatives for your f prime. Pause me, and then when you're ready, unpause. Okay, so I got this guy to be positive, this guy to be negative, negative, and positive. And so a trick that I used is I looked at the factored form. I know that the denominator is always positive, so I don't even care about plugging it in there because it's always positive. So all I have to do is plug it into those pieces. So -4 is going to be a negative times a negative, which is positive. So that was my trick to go kind of fast. So what does that mean? That means that f is increasing, decreasing, decreasing, increasing. So why is this decreasing, decreasing? There's a couple of possibilities. It could be a point of inflection, or it could be a discontinuity of some sort. And absolutely it is. Look at that. We have a VA when x is -1 because I don't have the same factored thing on top and bottom. So this right here is a VA. Okay? So see if you can write everything else out. Pause me, and then when you're ready, unpause. So increasing, where f prime is positive, decreasing, where f prime is negative. I have a relative max. Okay, at -3, -8. And I have a relative min at 1, 0. And make sure you're giving me this justification that f prime goes from negative to positive at x equals 1. All right. Okay, so the last thing we're going to do on this day is I want you to try to sketch a graph of the derivative if I give you the original function. And think about, this is increasing, this is increasing, okay? This is decreasing, this is decreasing. Um, relative max, relative min, relative max, okay? and see if you can think through that, and then I'm going to help you. So the first thing I do is I know that my relative max and mins here, since these were differentiable, these are my zeros. So I'm going to go put my zeros. Okay, the derivative of all of those, the tangent lines are 0. And then I know that this is a polynomial. The derivative is going to also be continuous and differentiable. Okay, so I know that if I'm increasing, that f prime has to go positive to negative. Okay, for that relative max, increasing, positive, decreasing, negative. So I know it does something like this. Then I know I have to loop to it, and does it make sense? Is all of this negative while we are decreasing? It absolutely is. Then we start increasing, so I know that I'm positive, but again, I have to loop back down to this guy because I need it to be fluid, but it's all positive. Okay, so the derivative's all positive while f is increasing. And now f is decreasing, so I need to be in the negative zone. So negative, positive. So there's my sketch. And then you go ahead and try the last one and see how you do.